All right. So all those people who wants to learn deep learning, or all those people who wants to understand as to how neural network works, or all those people who are new to deep learning, who have some sort of theoretical knowledge, who know about artificial neural networks, or who know about what is single layer perceptron, multi-layer perceptrons, or who has some sort of idea about who have some sort of idea about how does like deep learning works, artificial intelligence, can come to this page. Okay, just have to search for TensorFlow Playground or a deep learning playground. It is this website is designed by TensorFlow itself. So you guys know, like wherever, like if you have to perform any classification on image dataset or any unsupervised dataset, we have to go for deep learning. And deep learning may we use TensorFlow and Keras. Keras is built on top of TensorFlow, and both the libraries are developed by Google itself. Okay, so now let us try to understand, before going further, let us try to understand as to what all things are happening in this page. Okay, now first is, this is run button. Okay, this is run button. Once we have decided all the parameters in here, we'll try to run this. Okay, now first thing, what epoch. Now what do you mean by epoch? Right now, just like I've like what do you mean by epoch is, one forward propagation and one backward propagation is called one epoch. Okay, one full pass through. Okay, one full pass through, or in another words, what you can say is, one full pass through the training data set, okay, is called as epoch. Fine. So like here, like once the weights are assigned till here and then came back here, so it will be one epoch. The more the epoch, the better the answers would, the better the classification would be. But then again, I cannot like it will keep on increasing. You will see itself. Okay, it will keep on increasing, you will see itself. Now what is learning rate? Now learning rate is nothing but it's a hypermat parameters. Okay, it's a hyper parameter that controls how much model updates the weights in each step. Okay, so let me again tell you that learning rate, which we must have studied in, or you guys must have studied in regularization, in lasso and ridge regression, or gradient descent. Okay, so learning rate, I would again want to tell you that it's an hyper parameters, fine, that controls how much the model updates in each step. If I keep my learning rate too high, it becomes unstable. If I keep it too low, it becomes slow learning, very slow learning. Okay, so I have to keep it in a way where I have to tune it in a way that it gives me optimal performance. Okay, so this is my learning rate. Now this I have to see, I have many values. I have very less also, and I have very high also. So I've kept it somewhere in between like this. Now I have not kept it, it is by default kept it. Okay, now this is what it is. Next is activation function called tanh. Fine, activation function we have, I've told you, right, ReLU, sigmoid, linear, tanh and all. So what is activation functions? Again, activation functions, when I see after every output, right, so I may get different scaled outputs. Like say in my first propagation or first output value, I get 10, or in the next iteration I get 400. In the next cycle I get again 50, and in the next cycle I can again get say 1000, which I don't want. I want that to be in a specific range. Okay, specific range. Hence I have to perform some activation function. I have to keep some activation functions. Now that activation function can be kept for every hidden layers, or I can keep it for one, like I can keep it before one, like before the output layer as well. It depends on me. It's all hit and trial. Once, like if you're beginning, right, you can, like, you try to hit and try, hit and try, hit and try, and then once you get the hang of it, there you will be able to understand as to how these things are working. Okay, at that time your guess, or your guess will be more preciser than the day when you start to guess these things. Fine, so that is activation function, which we have to set must. It is must. Regularization. Now regularization also we have L1 and L2, lasso and ridge regression, but I have kept it none because this prevents overfitting. Okay, now my data set is very simple. Like I have only two classes. This is blue class, blue labels, and the yellow labels. So I don't have to check for overfitting. Afterwards, if we see what happens afterwards, we can do that. Regularization rate, again, it determines how regularization should be applied. Okay, so we can again, like learning rate, again regularization rate has to be given something, but at this time it is already by default में 0, because again regularization is done to overcome overfitting, but I know my data set is too simple, it is not going to go overfitting. Okay, so let us see. Fine, now this is a classification model, of course, because I have two classes in here, so I'll definitely go forward now. And what else, I have different kind of data sets. See, I have, like, if I choose first, right, so this data is first circular data or point data I have, and here is where I have two classes, but my data are segregated like this. Okay, we'll try to see that as well. For this I have very simple, and this is something called a spiral. It is the hardest. If you understand this, if you get good accuracy with this, you can understand that you have understood everything, but then again try to understand it from the beginning part. Okay, and then we have something called as rate to training to test data. Ratio, sorry, not rate, ratio to training to test data. Now half of the data set is used for training, and half of the data half is for testing, or called validation. Okay, now remember one thing, in deep learning we have validation and testing. In deep learning we have four parameters. First is accuracy. Okay, first is accuracy, second is validation accuracy, we have loss and validation loss. Now these four parameters has to be understood very carefully. Fine, and then a noise I have kept is 0. I don't know, like I don't have any noise in here, right? Noise means outliers. If I have noise I can keep something. Okay, batch size, I want to train 10 batches at the single time. Number of data points used in one training step, say for example 10, so 10 data points will be fed at single step or single training step. That is what it is called. Okay, so yeah, we have understood each and everything. Okay, and then I have input, so x1 and x2, so x1 and x2 you can see, right? So I have two data points, right, or two classifications. So these are my four neurons. I have kept it, or like I did not keep it, it is by default kept it. Only one hidden layers, I can increase the hidden layers like this. Okay, whatever, however I want to, I can increase the neurons as well, but right now I don't want to do that. Fine, so I have first hidden layer mein I have four neurons, in the second hidden layer mein I have two neurons. Each neuron applies weights and adds bias and uses the tanh. I have used as the activation function as tanh, and this is my, okay, so sorry, I beg your pardon guys, I really beg your pardon. We don't have only one hidden layer, we have two hidden layers. Then this is the output. I'm sorry, there was difference between, the distance was too high, so इसलिए we have two hidden layers. Okay, first hidden layer has four neurons and second hidden layer has two neurons, and this is my output. Fine, so everything's done. Okay, first neuron with the output range as this thing. Okay, 0 to 1 for binary classification, and then yeah, blue lines is my positive, and yellow lines orange lines or yellow lines is my negative. So forward propagation is happening with the blue line, and the backward propagation is happening with the negative line. And also in the documentation it is also mentioned in here somewhere. I just want to tell you, just a second, the thickness also indicates the weights as well. Just a second, I just want to confirm if that is the thing. Thickness should also, both blue shows which is neurons and orange line shows in the output layer the dots of see, it is here. The intensity of the color shows how confident that prediction is. No, it's not the thing. So here we will have intensity, but let us see, it's okay, no problem, no problem. We can just, orange will be my class 1. Let orange be my class 1, and this thing is my blue is my class 2. I did not do anything, I have tried to explain you each and everything. Once you get the hang of this, you'll understand everything in detail. Okay, let me try to run this now. Try to keep an eye in this epoch and this square, this classification. Okay, and also try to see the test loss and training loss as well. It has to decrease. The lesser the number, the better the accuracy. Okay, and I will stop somewhere. I will stop somewhere when I see that there is no changes which will happen in my loss. Okay, now of course when you try to do models, right, I'm sorry I'm taking too much of time. When you try to visualize model, right, you will not see this. you will not see this. After this, I'll also show you how my project works. I have done this rice grain data price prediction, or not data price prediction, the classification. I had 5 classes, so you will not get this as the output. This is just to make things simpler. You will get these values. So how would you decide whether your model is performing good or not? Where your validation accuracy and accuracy increases, and test loss and training loss, or validation loss or test loss, whatever it is called, decreases, and training loss decreases. So what I'll do is, just a second, I'll just now open that project so that it will be easy for you to understand. Just a second. Is it giving me good accuracy? Where is judgment? ठीक है, this is the one. ठीक है. So now this is how you will get, this is the graph you will get, and this is the epoch. I've kept it as 50, and you will get here accuracy loss, validation accuracy, validation loss. ठीक है. Now this is how you will get the things, and hidden layers I have verified here. Now this is CNN model, but then again it's a deep learning model. Don't worry about CNN, what is CNN and all. Just worry about how things we visualize in real world. In this website, you will be able to see the classification here, but in real life you will get only these values, and by this judging these values you have to decide. Let's not waste much time. Let me run this. See now, see this. Now if I pause this, right, see how the test loss and training loss is decreasing. Okay, how the test loss and training loss is decreasing, and after a certain point it has hit threshold. It has hit threshold. I mean, like, it is not decreasing after a certain point. The epoch was 214. Okay, the epoch was 214. I could have stopped it. Okay, let me just rerun this. After 150, I think it should learn. Okay, what happened? Okay, so every time it gives me different values. Okay, every time it gives me different values. नहीं रुक जा. I just want 150 epoch में. It should give me good. See, it is almost classified. Almost classified. See in here, this circle, this blue circle is exactly classified. All the blue dots is within the blue circle, this white, like white circumference, and all the orange dots are beyond that white circle, right? So it has almost classified, and the test loss, you can see test loss is 0.029 and training loss is 0.020. If you multiply it by percentage, so it is 2.9 and 2%. It's a very good thing. And also this color intensity, see color. Also I would want you to focus on the thickness of these weights. Blue means the forward propagation, yellow means, orange means the backward propagations, right? So this, see, it is weights. If you see here, 0.66, the weight is 0.66 in here, and the weight is 0.58. But here if you see, weight is 0.95, which means it has classified. Here the weight is 1.1, so it has increased, right? It has learnt more. 1.1. If you see, but if you see the backward propagation, so it has reduced its weight. Okay, reduced its weight. And if I see in here, minus 0.46, which means it is trying to understand my data. If I give, see, even like only in 100 epoch, I did not change anything in here. It has already learnt a lot of things, and it has already classified a lot of things. All right, so let us go for different data set. Okay, let us go for different data set. Let's not change any parameter. Let us run. Let us see how much epoch it takes to understand this. Okay, see, almost 80. It has taken less time than the previous data set to learn, because I have got 0.015, which means these all parameters, right? These all parameters which I have kept: learning rate, activation, regularization rate, problem types of classification we have, and this ratio, noise, batch size, and all. So it is almost tending to perfect, right? So this, it has taken 80 epochs. I don't have to do anything for this. Let us see. See, after like 10 epoch, it has like, it's a clear-cut segregation, right? Clear-cut segregation as to one line, it will segregate my both the datas, right? So this data set was more difficult than this, and this data set was more difficult than this. Let us now look for this. Okay, with the same parameters, let us try to visualize this, or let us see how much epochs it will take to understand this data or classify this data. Now try to focus on epochs and this aggregation here. See, now try to understand. Just first thing is epoch 500, more than 500. Of course, if 500 epoch couldn't do anything, right? How come like 1000 epoch? What will be the difference in 1000 epochs? Right? It will not have, like, it will not do anything. Fine. So my these parameters clearly is not sufficient for me to understand this data. Okay, epochs is giving me the first hint that these parameters are not sufficient for me to understand this data. Second, see here, the line is trying to segregate, but it is not segregating each points. See, by this we can also see, the training loss or the test loss is not decreasing much. It started with 0.5, it is still at 0.4 only, right? So hence it is not giving me good accuracy. So what at this time can we do is, we can increase the number of neurons or hidden layers. We can increase the number of neurons. Okay, we can increase in here. Let us try now. Me increasing the number of neurons, me increasing the number of neurons is not giving me anything. So what I can do is I can change something. Okay, I can change some of the other things. Fine. What I can do is, first layer I can include or increase to 8 neurons. Okay, first include to 8 neurons. I can in like I can keep 8 neurons for my second hidden layers as well. Fine. Now since it is binary classification, I would want to keep it as tan h itself, or sigmoid will also do. Let us try. I'm not trying to do anything, but let us try with tan h first and then try to see. Okay, learning rate, now I would want to reduce it to 0.01 because it is not giving me good values, right? 0.03. Fine. I can keep my regularization to L1 lasso, because the again it is not giving me perfect accuracy, so I'll try to hit and try. Okay, again I'm not explaining a lot of thing, what is L1 L2 lasso, ridge regression, what is tanh, all the details I'm not discussing. I'm just trying to tell you how you can choose parameters so as to get the good values. Okay, batch size is 10, I would want to keep that batch size. Okay, and also I would want to keep, let us see, mm, let us see with this. Okay, let us see with this if we can try to classify, or if it is trying to get good results. No, 452. Again, it's not giving me good accuracy. Again, the loss is not decreasing. Okay. What we can do is, I can remove this. Sometimes what happens is, let me add here this also, and let me choose Relu. Relu takes a lot of time to train. All right. So let us see now. It is trying to understand, right? Yeah, it is trying to, but is it decreasing? Is it decreasing? Yes, just a second. See, after 908 epoch, right, after 908 epoch, what it is trying to do in here is learning parameters. See, if you can see, all the things are classified perfectly. It is like a gym guy stretching his muscles, hand muscles or something like that. Fine. So now you see 0.06, 006, 0.007. But I think I have made my model too complex. I guess, I think. Okay, I think I have made my model too complex. So now what I can do is, I can increase my input features. I can increase my input features, and I would, let's try to decrease my batch size as well, because I want my data to learn a lot. Okay, I want my data to learn a lot. And also let us take out one, okay, hold on. Let us take out um, 2 ही रखते हैं. Fine. And keep it 8 and 4, or let us take like 6 and 4. See, the more the hidden layer, okay, the more the hidden layer, you're keeping your model, like you are keep making your model too complex, which you don't want to at that time. Okay, which you definitely don't want to at that time, right? So this I have kept. Okay, batch size 5, noise 0, training size I have kept it as 50% only, learning rate 0.1. Let us go back to tan h, okay, because that takes a lot of time. See, 800 epoch mein that learned. That is the problem with relu, it takes a lot of time to learn. Okay, I would want to keep it L1. Okay, tan h activation, tan h activation, regularization, let it be L1. Regularization rate, let us now keep it as 0.001. Okay, and now let us try to, okay, let me keep it 6 and 4. I think it should run good now. Let us see. No, this is not performing good. Okay, this is not at all performing good. So what we can do, is we can change something. Okay, so tanish nahi, relu was giving me good accuracy, right? So let me run this again. I think it should perform good now. It should perform good now. Yeah, I think after 400, right? So it has fitted good. See, everything is classified in here. Everything is classified in here. So some things, some part are remaining in here, this white patches. Okay, so I think, yeah, so my aim should be to reduce the epoch to get the maximum values. Yeah, at the same time I shouldn't be making my model more complex. Of course, if I increase one more hidden layer, right, of course, if I increase one more hidden layer and keep it as 4, right, so it is definitely going to give me good accuracy. Yeah, see, after 495 I have got very less loss for both test and training, and I have gotten all the segregated points. See, the graph in this try to generalize a lot of things. It has tried to, like, मर मर के सीख रहा है ये, हिंदी में अगर बोलूँ तो. Fine. So I hope you guys have understood. So if you have like if you want to learn more, right, try different things in here. How things will be, right, is, see, in this neural network, right, in this neural network, so you have two classes, right, dots, and both the dots, the color dots. But in real life you will have different segregations. Say I had this project which I have done using CNN. So I had 5 classes of rice. I was doing classification: arborio, basmati, ipsala, jasmine, and karagedak. So these are 5 kind of rice grains we have. Okay, so what did I do in this project is very simple. You don't have to do anything. Like, deep learning, I feel it is more simpler than machine learning. Okay, machine learning or tabular data. So there is no hardcore pre-processing which you have to do. First, I have imported a lot of things. Again, like image data generator, because I have to read it from my local, because the data are stored in my local machine, and then from there I have to do different things, right? I have to do like I have to make a training data, test data, and validation generator. So image size I have kept as 224 pixel. Okay, image size I have 224 pixel by 224 pixels. You guys know about it. Batch size, like see in here, we have kept batch size as 5, right? So means, which means 5 images will be fed in for first for one training cycle. Okay, so here I've kept it as 32, or you can keep it as say 64 as well. So first I'm trying to read my data. So from image gen, I have imported image gen, read my data, and I am converting it into, now I'm rescaling it into 1 by 255, right? Yeah, so this is all I'm doing, data augmentations I'm doing. I want my data to learn, or I want my model to learn by rotating the image, by zooming the image as well, by horizontal, by doing horizontal, like from all the angles also, and that is there. And validation split, I'm taking 10% of the data from that as validation. Okay, from that I am defining train generator, which means this is my training data, like we do x train x test, right? Like this we are doing training generator, because here we don't have two variables, right? X and y, we don't have output, we have only classes. And then is my training. Now training, like in the tabular data we do x train and y train, we don't have x and y here, right? We only have classes. Okay, we only have classes, so we don't want x train y train. We have only train generator here. So train generator target size I have given image size cross image size. I want to reduce all the pixels to 224 by 224. Batch size, color mode, it was grayscale. I kept it as grayscale because it was in grayscale. But then again, after some time I realized that if I go on to info part over here, so I can see something like called, see, RGB. It was in RGB, but even though it looks like a grayscale to me, but the default pixel is in RGB colors, and also the size was 250 by 250. But then again, this data is clean. I know कि every of my image is my 250 by 250, but what if there is one image out of 15,000 samples which is out of this dimension? At that time my model will not work. Hence even though my data is clean, but then again I have to mention that. Fine. Hence I have kept it as image size by image size. Color mode I kept it as grayscale, but then again change it. By default it is RGB. If you want to train by grayscale, you have to mention that. Batch size, class mode categorical, because I have my 5 categories. Subset is my training. I want my training to like train on my training data, right? I want to shuffle as well. Shuffle, I kept it as true. Validation, val generator. So validation, so like in x test we have, in the machine learning tabular I have validation generator here. I have defined that. Okay, so once I execute this, I have got like 2250 samples belonging to 5 classes for training, and for validation I have kept it as 250. Class names I have a priori, basmati, ipsala, jasmine, and karagadic, and I'm printing 3 images of 5 classes. Okay, and then after that I'm importing. Now this is my hidden layers. Now these are my sequential models. Okay, in CNN, don't worry about it. You don't have to. I'm just trying to explain you the introduction of deep learning, how things work out here. Hence, this is what it is. See, convolution 2D. So filters I've kept 64s. Okay, kernel size I've kept 3, strides 2, padding same, activation ReLU, input size 224 by 224 by 3. So there are 3, the shape is 3 for any image classification: length, width, RGB colors. Fine. So same cheese. My first layer is this, first hidden layer is this, second hidden layer is this, third hidden layer is this, and then once all the things are done, I flatten it into 2D shape. Okay, now and then I've added dense layer with 5, because I had 5 classes, so 5 and activation. Now at the last I have made it soft max. Okay, don't worry about all the technicalities, what is filters, what is kernel size, what is strides, what is padding. Don't worry about this thing. Filters is like 64 pixels, kernel size is 3. Okay, which means like 3 by 3, 3 by 3 pixels I want to feed it at the single time. Okay, 3 by 3 pixels. Strides, how many strides I want my next iteration to have, 2 cycles I want to have. Padding I want to keep it as same. Activation, it is a ReLU. Lot of things are there, we'll study it sometime another. Take it. Now these are my, what am I defining in here is these things, these these first, second, third, my hidden layers. I have here, it is by default I have set it over here itself. I have to code it in this. That's it. That's the only difference. Okay. After that, once my hidden layers are defined, I have to compile, keeping an optimizer in mind. Whenever in doubt, keep optimizer as Adam. Loss is categorical cross entropy because it's my categorical data, and metrics I want to analyze accuracy. Okay, and then I have defined my epoch as 50 and defining early stopping, which means um, yeah, say for example, see in here in this data. So let me just take simple, let me run this. Yeah, see, after this iteration, say suppose after 30 epoch, it is giving me same results, right? So it is as good as you not doing anything for these epochs. I'm just making my model more complex. I'm just forcing my model to learn more, but it is not learning. So I want to early stop here. Hence I hence I defined early stopping in here. So what will happen? Early stopping, monitor. I am monitoring validation accuracy in here. I'm monitoring validation accuracy. So here, if you see, I gave you example of test loss and training loss. Okay, both are same, right? Both are same, but then again, both are same. So if you see, if you change something, you will see two different graphs. This is combination two different graphs. Okay, so here you are seeing it as training or test loss, but here I am giving validation accuracy. Where is it? Validation accuracy. I want to see validation accuracy. Patience I've kept it as 10. Matlab, in this 50 epochs, if I have my 10 epochs where my validation accuracy is not increasing by marginal, I would want to stop there. Restore best weights, yes. Out of that 10 patients, okay, out of that 10 patients, if I would want to get the best out of it, right? Verbose 1. And then once everything is done, I have defined everything. Now I would want to run these things. I would want to compile, right? So history is equal to cnn.fit. I have fitted it. Train generator, I would want to train on my training data. Epochs is equal to epoch. I've given validation data is val generator. I have defined it here. Here val generator, callbacks, early stopping, right? So once I hit this, I would have given you like this. I would have run this again, but it takes 14 seconds for one epoch. So 50 into 14, if you do, it takes 700 seconds. So if you divide by 60, somewhat 10 minutes, 11 and a half minutes. Keep a close eye on these lines. 14 seconds it has took for one epoch to complete. 179 milliseconds per step. Accuracy is 0.40 first in the first epoch. Loss is 1.36. Validation accuracy is 72. Validation loss is 61. In the first epoch, like the way the example I gave you just a while ago, जब आप फर्स्ट पेंट करते हो, कोई अगर पेंट कर रहा है तो दीवार में फर्स्ट लाइन ऑफ कोटिंग मारते हो आप, तब वो इतना अच्छे से नहीं आता है, बट वो दिख रहा होता है कि हाँ पेंट किया है, बट इट इज़ नॉट दैट शाइनी और इट इज़ नॉट गिविंग यू दैट सेटिस्फैक्शन. सेकेंड लेयर, यस, यू फील समथिंग कि हाँ कुछ तो हुआ है. थर्ड लेयर इज वेयर यू गेट गुड थिंग्स, लाइक यू अंडरस्टैंड कि हाँ ये अब अच्छा लग रहा है. फोर्थ लेयर इज फॉर लाइक योर सेटिस्फैक्शन. Similarly here, I've kept it as 50 layers. Okay, so in every 50 layer, in every layer or every epoch, it is learning some or the other thing. See, first accuracy was 40, second it has jumped to 74, third it has jumped to 80, fourth it has jumped to 82, फिर 82, फिर 82, 82. Now after certain point it is not increasing much. If you see, it is my third epoch, or rather fourth epoch, 80. If you see 27th epoch, it is 89. Which means in the first three epoch it has increased till 40, 50, 60, 70, 80, like 40% or 0.4 points it has increased, but in the first three epochs. But in the next 25 epoch it has only increased 9, which means again you can get back to the same example. In the first paint layer, in the second you see drastic change compared to third layer to fourth layer, right? So that is what is happening over here. So this again, like keep an eye on this as well. Loss, it is decreasing. Validation accuracy is also increasing. Validation loss is also decreasing. This we can visualize, and this is my layers, like whatever I've defined. Okay, now this I'm defining, like I'm retrieving my accuracy, val accuracy, validation accuracy. Final, since now You might be asking me, why did this early stopping did not work? Because I kept the patience as 10. It's too much. In the 10 epochs, it's like in the 10 epoch it will definitely increase. Okay, if I would have kept it as 5, it would have stopped somewhere around 39. Okay, you guys can try it. Fine, this project is definitely mentioned in my GitHub. You guys can definitely try it. Fine. So hence it has given like 50 epochs. Now after 50 epoch, in the 50th epoch, my what is my accuracy? 96.71, and a validation accuracy 95. That is what, 96.98, and validation accuracy is 95.6. Loss is 0.9. Validation loss is nothing but test loss here, which we have seen. Test loss. Okay, test loss. So test loss is also fine. So my model is perfectly fine. Now if I want to plot, see, this is the graph. Now why this yellow line is my validation accuracy. Now it is going zigzag, 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 which means it is trying to generalize, which means it is trying to learn, which means it is trying to cope up with the validation accuracy. At the same time, my loss is also decreasing. Loss is also decreasing. And also one more observation what you can make over here is, in the first epoch, my training accuracy was too less compared to validation accuracy, because in the first time when you see a data, right, so your accuracy is very less. Validation accuracy will be compared to training accuracy, it will be more. Why? Because it has already seen it has in the training data is already seen. Similarly for the loss. Fine. And then I'm defining my evaluation matrix, and also I'm defining my confusion matrix, and then I'm predicting. So it is predicting 100%. Yeah. So these are not of your things. Fine. So yeah, this is what my project is all about. Yeah, if you have any doubt, you can ask me, no issues on that part. Yeah, so every project is this project is uploaded in my GitHub account as well. You can find the link.